So for this question, we're dealing with a normal distribution. They tell me I've got a normal random variable with a mean of 266 and a standard deviation of 16. And then they're telling you they would be useful. I'm telling you folks, you want to do this. I mean, even if you aren't going to use the empirical rule, you want to make a little sketch. It'll help you out so much. And then the empirical rule, or the 68, 95, 99.7 rule, tells us that within 3 standard deviations, practically everything will fall in that range. So what I'm going to do is I'm going to take the standard deviation, add the standard deviation to the mean 3 times. So I'm doing this off screen. I'm taking my calculator and I'm adding 16 3 times. So I added 16 to 266, and that's 282. Then I added 16 again, and that's 298. Then I added 16 again, that's 314. And then I'm going to subtract 16 from 266. I think I can do this without a calculator. Let's see, that's 250. I'm going to subtract 16 again, which is, let's see, 10 would be 240, 6 more would make it 234. And then 16 more would be, let's see, 10 would make it 224. And then 6 more would make it 218, I believe. Let's make sure that I did that right. 266, I don't want to do all this work and get it wrong. Yep, those are correct values. Okay, so now just to refresh your memory from the reading, we're going to use the empirical rule, which is another name for the 68, 95, 99.7 rule, and that's all this problem is asking me to find so far. So this is plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. So the probability is 0.95. Notice that's the 95, that the pregnancy, 95% of the pregnancies will last between the 2 standard deviation mark, which, if I'm reading this graph that I made correctly, that's going from 234. Let's see, will it let me select it? And I got to go back to the mouse. That'll take it from 234, which is 2 standard deviations below the mean, to 2 standard deviations above the mean, which is 298. 1, 2, yes. Now the shortest 16% of the pregnancies, let's see, will it let me undo my writing here? Yes. So the shortest 16, is this good? Let's change this. If this represents 68% because of the 6 to 1 plus or minus 1 standard deviation, that tells me that 100, whoops, let me change my ink. Let me write it again in case somebody can't see that. 100 minus 68% is 32%. And since this is a symmetric distribution, half of that's on each side. So this is 16%, or about 16%, and this is 16% up here. Now notice I really am going down to negative infinity. I'm not just stopping at 218. That's an important thing to note. So the shortest 16% of pregnancies last less than, and the answer is, I'm hoping you said 250. Okay, the probability that pregnancy lasted longer than 314 days, well, 314 is way up here. Get my pointer going. 314 is way up here, which is 1, 2, 3 standard deviations above the mean. So then what we got to worry about is what percent of this distribution is up that high. Now let's see if I can't get this cleaned up. Whoops, I don't want to clean that. Undo. So then I'm going to grab my handy dandy pencil again. 3 standard deviations denotes 99.7%, about 99.7% of the distribution. That leaves 0.3%. And we're going to cut that in half, which tells me only 0.15%, or 0.0015 if we make a decimal. Remember, we're going to move that decimal point over 2 places. Will be better than 314 days. Those poor mothers. So 314 is, oh, here we go, 0.15, 0.0015. There's a probability of 0.5 that a pregnancy will last longer than, well, 0.5 is half. This is a symmetric distribution, so that tells me the mean and the median are the same. So longer than the mean is what we're looking for, so longer than 266. And let's see how I did. Huh? Oh. I bet you it's because I did some editing here. Well, I know I'm right, so we'll just have to go with it. Sorry about that, but that's how you do that problem.